Okay, number one, 3x squared minus 13x minus 10. The instructions on this one will say completely factor the given trinomial. And anytime you see that word factor, always make sure you check to see if there's a greatest common factor. Something that you can take out of all of these. In this case, maybe try to take out an x, but you can't take an x out of everything. And if you look at the numbers 3, 13, and 10, nothing that they have in common. So on a few of these, you will have something that you can take out, but in this case, no greatest common factor. The next thing, typically with a trinomial, you'll factor it into two parentheses and then go from there. But if you've got a number out in front of the x squared that isn't one method you can use is what's called the AC method, where you're going to multiply the coefficient at the front in front of the x squared and then multiply the constant on the end. So 3 and negative 10, if you multiply those, you get negative 30. And then what we're going to do is we're going to go through a list of factors that could potentially make 30. And then we're going to replace this negative 13x with it. So this is a multiple step problem. So starting with over here with the factors of 30. So 1 and 30 could potentially multiply to be negative 30. And I'll go ahead and one of those would need to be negative if they multiply to be negative 30. But I'll deal with the signs here in a minute. 2 and 15. And I'll usually on the left 1, 2, 3. I'll go through these methodically. 3 and 10. 4 doesn't go into 30, but 5 and 6 multiply to be 30. And then once you've got around to the right side, then you know you've got a comprehensive list. So here we're looking for a pair that we can make negative 13 out of. You could make negative 13 out of 2 and 15. You could make negative 13 out of 3 and 10. So with the 3 and the 10, though, it would need to be negative 3 and negative 10 in order to add to be negative 13. And with the 2 and 15, the 15 would need to be negative. The problem with the negative 3 and the negative 10 is it multiplies to positive 30. And we want it to multiply to negative 30. So this pair, even though it could add to negative 13, we're not going to use it. So back up here, 3x squared, just rewriting it. But we're going to rewrite the negative 13x. So I'll do that in blue. So going to use this 2 and negative 15 here. And you'll want to make some kind of determination about which would be a better fit. I'm going to put the 15 with the 3 and the 2 with the 10 because they have common factors. So negative 15x and positive 2x. So using the coefficients and then tacking on an x. So these actually are the same as negative 13x. So we're just replacing it with two terms instead of just the one. And then from there, we're going to do factor by grouping, which we've done before, where you pair off the first two and then factor something out. We're going to pair off the third and fourth terms and then factor something out of them. If you look at this first pairing, 3x squared and negative 15x, you can take out a 3 and also an x. And then rewrite what's left when you do that. When you take a 3 out of 3x squared and an x, you're left with just an x. And negative 15 divided by 3 gives you negative 5, and we took out that x. Moving on to the next pair, 2x minus 10, you can take out a positive 2. And then we'll rewrite. When you take 2 out, you're left with x. When you take negative 10 divided by 2, you get negative 5. And then ideally, you'll have a factor in common, is x minus 5, and another x minus 5 there. So we're going to take that out. And then we're going to multiply by the things that were left. This should look somewhat familiar. It's something that we've done in the previous section. Number 2, 8x squared minus 18x plus 9. So again, factoring. First thing, GCF, greatest common factor. So you're looking to see if there's anything you can take out of all of these. Can't take x out of everything. 8, 18, and 9 don't have anything in common, so no greatest common factor here. Second, since this number in front of x squared isn't 1, we'll multiply the 8 and the 9 and get 72. And then we're going to make a list of things that multiply to be 72 and that can add to be negative 18. So 1 and 72, 2 and 36, 3 and 24, 4 and 18, 5 doesn't go in, 6 and 12, 7 doesn't go in, and then 8 times 9. So again, we're looking for a pair that we could make, that we can add to be negative 18. So we could maybe make negative 18 out of that if both of them are negative. Can't make negative 18 out of that. Can't make negative 18 out of that. If we add those, we get 27, or if we subtract them, we get 21. Can't get negative 18 out of that. Can't get negative 18 out of that. So these two, negative 6 and negative 12, they would add to be negative 18. They would also multiply to be positive 72. So back over here, going to rewrite 8x squared, and then replacing the negative 18x with negative 6x minus 12x plus 9. And then going to group off the first two, group off the third and the fourth, and factor them. So in the first pair, we can take out a 2 out of both. We can also take an x. Then we're left with 4, 8 divided by 2, and we took out one of the x's. Minus 6 divided by 2 is 3, and we took out the only x that was there. Here for the second one, make sure you notice that the term there, the 12 that we're factoring that starts, we want to take out a negative in this case. 12 and 9 both have a common factor of 3. So we're going to take out a negative 3. Can't take x out of both of those, and rewriting it, negative 12 divided by negative 3 is 4, and we still have an x there. 9 divided by negative 3 is negative 3. Then we've got that common 4x minus 3, and we're going to multiply that by the things that were left, the 2x minus 3. Number 3, 6x squared plus 34x plus 40. Anytime you see factor in the instructions, check greatest common factor. And in this case, it does look like there's something that we can take out. A 2 we can take out of everything. So we'll start with that, and then we'll rewrite with that one factor taken out. So 6 divided by 2 leaves us with 3 and then x squared. 34 divided by 2 leaves us with 17 and an x. And then 40 divided by 2 leaves us with 20. Second thing, you'll want to notice that the number in front of x squared is not 1. So we're going to go ahead and multiply these outside terms, the 3 and the 20. That will give you 60. And then we're going to replace this middle term with some pair of factors that multiply to be 60 and that also add to be 17. So 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. 7 doesn't go into 60, 8, 9 don't go into 60, and then you're back up to 10 on the right side. So again, looking for a pair that can add to be 17. Can't get 17 from that. Can't get 17 from that. You could get 17 from that if they're both positive. Could get 7, or actually, if one of them's, if the 3 is negative, you could get 17 from that. With the 5 and the 12, if both are positive, you can get 17. 4 and 15, we can't get 7 from. 6 and 10 could add to 16 or subtract to 4. So here we've got to decide between two pairs. So the 5 and the 12 multiplies to be positive 60. Also adds to be positive 17. And the negative 3 and 20, it does add to be positive 17, but it multiplies to be negative 60. So this one we're actually not going to use because we want it to multiply to be positive 60. So I'm going to rewrite this. For now, I'm just going to ignore the 2, but we do want to make sure in our final answer we've got the 2 out front. But 3x squared, and then replacing the 17 with, I'm going to go ahead and put the 12 with the 3 since 5 and 3 don't have a common factor. But positive 12x, and then positive 5x, and then plus that 20 on the end. And then we're going to pair off the first two, pair off the third and the fourth term, and then factor. So we can take a 3 and an x out of that first pair. 12 divided by 3 leaves a 4. In the second pair, we can take out a positive 5. And that leaves x plus 4. And then you've got that x plus 4 that's common. I'm going to multiply it with the 3x plus 5, and then be extra careful that you don't forget that 2 that we took out at the very beginning. Number 4, 16c to the fourth x plus 24c to the third x plus 28c squared x. Factor the given trinomial. Greatest common factor, first thing. So here, 16, 24, and 28, you can take a 4 out of. We've also got a c in every one of those terms, so you want to take out the most number of c's you can, which is 2 of them. You can take 2 out of every single one of those terms. We can also take out an x out of every single one of those terms. So we'll do that, and then we'll rewrite what's left. 16 divided by 4 leaves 4. We took out 2 of the c's, so 2 of them are left. We took out an x, so no x is left there. 24 divided by 4 is 6. We took out 2 of the c's, so that leaves 1. 28 divided by 4 leaves us with 7. We took out both c's. We took out the x. So that's all that's left there. Next, this term in front of c squared is not 1, so we'll go ahead and multiply 4 and 7 and get 28. And we're going to want to find a pair of factors, if we can, that add to be 6. So with 28, we've got 1 and 28. We've got 2 and 14. 3 doesn't go into 28, and then 4 does, and 7. And we're hoping to find a pair that can add to 6. 1 and 28 does not add to 6. 2 and 14, if you add those, you can get 16. If you subtract them, you can get 12, but can't get 6. And then 4 and 7, you can add them and get 11. If you subtract them, you can get 3, but you cannot get 6. So it turns out none of those pairs work, and this is the only factoring that we can do. Took out the 4c squared x, but that's it.